This video covers AC dangers for boats and swimmers. We will cover AC and DC boat wiring practices. Here you see Captain and Mate Farmer aboard Trace 1 with passengers on a cruise from Knoxville to Chattanooga. We sailed aboard a Catalina 25 for 23 years. Captain Farmer is a 100-ton master with sail, and he and his first mate sailed out of Panama City for weeks at a time and aboard multi-hulls in the Caribbean. We currently sail a 29-foot Catalina out of Knoxville on the Tennessee River. We have over 50 years of experience, both power and sail, inland and offshore, recreational and commercial. Captain Farmer is a Power Squadron full educational certificate holder, teaching basic boating through Celestial. Here you see an example of the old 110-volt household AC wiring. The driven ground rod near the home service entrance provides a local safety ground. Old outbuilding wiring is very similar to marina wiring, and here we also have a driven ground near the master breaker box. On the marina power pedestals, you have some type of twist lock receptacle, and here you see the 120 volt 30 amp version. Your shore power cord is heavily insulated and waterproofed, and it goes from the power pedestal to your boat with a locking collar. 30 amp 125 volt locking receptacles are the most common, but there are other variants, and you may need adapters in some marinas. There can be AC grounding problems aboard your boat. If the incoming AC ground is connected to the boat's central ground, it provides an AC leakage path to the boat master ground. The boat master ground is connected to the prop shaft and can provide an AC leakage path to the water and swimmers. This is a very dangerous situation and can lead to electric shock drowning. The Electric Shock Drowning Prevention Association recommends never swim in or near marinas, docks, or boatyards. Tell others about these dangers. If you're a boat owner, have your boat inspected by a certified technician. And they also recommend signs be posted to warn people of these dangers. The ESDPA neither promotes nor endorses the use of current detection devices as green light for swimmers. Electric shock drowning can result from paralysis caused by electric currents in the water. If the electric current is high enough, electrocution occurs. It only takes a very small current to cause problems. 10 milliamps can cause paralysis and drowning, and 60 milliamps can cause heart failure. In fresh water, the human body is much more conductive than water itself, so stray current flows through the body in fresh water. 3 wires on AC wiring are needed to protect you from equipment shorts and leakages. If the metal case of a tool or light shorts to the hot power wire, you can be connected to the 120 volts AC. Especially if you're in a damp or wet environment, the body could become an unwanted conductor. Larger amounts of AC can paralyze or kill you. Always use 3-wire extension cords, and never, never, never cut the green wire ground off of anything. Your bathroom, kitchen, and boat should have ground fault receptacles like the one shown here. They're designed to protect against electric shocks and potential fires. They have a sensing mechanism that monitors current flow, trip mechanism that can cut the power off, a reset button, and a test button. When it comes to electricity, safety has always been a major concern. Ground fault receptacles can reduce the severity of shock greatly. Quick-to-react outlets like this are required in new homes. GFIs may nuisance trip in damp environments, but they are still needed for your protection. Here's an example of a main breaker panel in a sailboat saloon. Your boat should have a master double pole breaker within 3 feet of the shore power connector and a secondary connector on the saloon power panel. Here you can see the location of my master breaker, and you need to find it on your boat so you know exactly where it is in case you need to use it. If your boat is grounded to a pedestal ground, stray currents can drown a swimmer, erode your prop shaft, and affect nearby boats. The safest way to prevent this is also the most expensive with an isolation transformer. The best way that I know of to isolate is by using a galvanic isolator like the one pictured here. You need a master ship's ground bonded to all metal aboard the boat, including the engine, with a number 8 or larger bonding wire, and copper foil is even better. I have an HF radio aboard my boat, so I have to isolate its ground with capacitors as shown. With lightning, nothing is guaranteed. A masthead discharge connected to your central bonding system may help and should provide a 3rd-degree cone of protection. Please avoid thunderstorms in every possible way. You need to use proper wire sizing aboard your boat, especially for your VHF radio and navigation equipment. It should have less than 3% loss. You need 2 wires to everything. The decision as to whether you should do wiring yourself depends on your knowledge and training. If you're not trained, please get professional help for your safety. You shouldn't trust electrical safety to chance. Always get professional help unless you're trained and are absolutely sure you know what you're doing. It's not worth the risk to passengers, the boat, and possible electric shock drowning. Don't let electrical problems spoil your boating enjoyment. Thanks for viewing this video, and if we can be of any assistance, please don't hesitate to contact us, as our 50 years of experience may be helpful to you.